In this video, we're going to start talking about factoring, one of the more commonly used parts of algebra, especially with shortcuts. If you're really good at factoring, it can make a lot of problems a lot quicker, a lot easier. So you want to be pretty comfortable and familiar with factoring. So today we're going to start off with greatest common factor and talk about how that's the opposite of distributing. All right, so right here we have an example of distributing. I've got a 3 being multiplied to the parentheses. So if I was to distribute, I would want to multiply this 3 to all of the terms on the inside of this parenthesis. So I would multiply the 3 to the 4x, and I would also multiply the 3 to the 5. So if I were to go ahead and distribute, this would give me a 12x plus 15. Factoring is when you do the opposite of that. Instead of multiplying into the parentheses, we're going to divide out in front, and then it's going to create parentheses. All right, so if I was to do the same exact problem, let's say we had 12x plus 15, you would look at this and say, you know, what factors do those two terms have in common? What does the 12x and the 15 both have in common? If I look at those two terms, I could actually divide both of them by a 3. Now the question I have to ask myself is that the greatest common factor? Is that the biggest number that they have in common? You always want to look at this and take out the biggest thing that they have in common, and that's why this is called the greatest common factor. So I look at that term and that term. I need to know what do they both have in common. I can divide both of them by a 3. So when I do decide to factor out, in other words, I'm going to divide out instead of multiply in, I'm going to put this on the outside of a parenthesis. Okay, now I need to divide each of these terms by the 3. So 12 divided by 3 is 4. I still have an x plus. Now I need to do the 15. 15 divided by 3 is 5. So you can kind of see how distributing is the opposite of factoring. I'm going to go ahead and do some more examples of greatest common factor. A lot of times this is referred to as GCF. All right, another example of GCF, or greatest common factor. Let's say we've got 5x to the third plus 15x squared minus 10x. Okay, so now I have 3 terms, and I'm asking you, what is the GCF? What is the greatest common factor? So we need to look at all the terms and try and figure out what is the biggest thing that I could possibly divide all 3 terms by. The first one that's popping out at me is a 5. If I was to take a 5 out, or divide all of these pieces by 5, looks like 5 goes into this term, 5 goes into that term, 5 goes into that term, but that actually isn't all. It's not the greatest common factor because there's more things that I could take out of that. Don't they all have an x as well? Yeah, so I actually have to take out the 5, but I also have to take out an x. So the GCF, the greatest common factor of this problem, is 5x. Okay, that's what the GCF is. If I asked you to actually factor out the GCF, then that would create a parenthesis, and I would need to divide out of all of these terms a 5 and an x. So if I go ahead and do that, 5 divided by 5 is 1, so I would have an invisible 1 right here. X to the third divided by x, if I take away one of those, I would still have x squared. So I have a 1x squared here, plus 15 divided by 5 is 3. If I take away an x, I would still have 1x left over, so I have 3x here. Looks like I have a minus. 10 divided by 5 is 2. If I take away that x, I don't have any more x's available, so that's just going to be a 2. So when I factor out the GCF, I end up with 5x times parenthesis x squared plus 3x minus 2. You can always check to make sure you have it right by multiplying back in or distributing and seeing if you get this original problem. So 5x times x squared. would give me 5x to the third. That is correct. That's what I have up here. Now I distribute to the 3x. 5 times 3 is 15. X times x is x squared. So I look above. Yep, that's correct. 5x times a negative 2. 5 times negative 2 is negative 10. Then I need to tack on an x. I get negative 10x. That was correct. This is the factored answer to this. All right, we've got another one here. We got 6x to the fifth plus 9x to the third plus 3xy. I just threw a y in there to see what would happen with that. So I need to look at each of these terms here and see what do they have in common. In fact, what's the biggest or the greatest thing that they have in common? So I look at the 6, the 9, and the 3. Right off the bat, it looks like they have a 3 in common. What else do they have in common? This has x to the fifth. This has x to the third. That has x to the invisible 1. So what do they have in common? They only have one x in common. These guys have more than that, but they all have one of them in common. So I could take out a 3 and an x. I can't take more than that because this guy doesn't have enough x's to take more than that. Now, do they all have a y in common? No, these don't have any y's at all, so the greatest common factor, the GCF, is just going to be a 3x. So if the question says, what is the greatest common factor, we'd stop right there and say, da, 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 da. There is my GCF with sound effects. If the question says, factor out the GCF, then I need to actually take this out. So that would create parentheses. Let's see, I divide it. 6 divided by 3 is 2. X to the fifth, and I'm taking away an x, would leave me with x to the fourth, plus 9 divided by 3 is 3. Taking away an x out of that would give me x squared, plus 3 divided by 3 is 1. X divided by x is also 1. That would just leave me with a y left over. So that would be taking out or factoring out the GCF, the greatest common factor. There's other examples where they could try and spice things up and try and confuse you. When I look at something like this, I see that there's an x minus 4 in common. It helps to kind of know where the terms are. Okay, that whole thing is the first term. This whole thing would be the second term. Terms are separated by addition or subtraction signs. And so this whole entire thing, which has multiplication in it, this whole entire thing is separated from this whole entire thing by an addition sign. So this would be the first term, second term. Now you ask yourself, okay, what do the terms have in common? What's the biggest thing they have in common? Well, they both have this parenthesis thing in common. So if I was to divide it out or factor it out to the front, I'm going to pull this out to the front. That would leave me with x minus 4. But remember, anytime you divide something out to the front, it creates a parenthesis. So it's this thing times all this stuff inside, because if I were to distribute, I should get my original question back. So the question is, when I take out this x minus 4, what's left over? Well, if I take away the x minus 4, I still have a 3 left here. And then if I took out this parenthesis x minus 4, I would still have a y left over. And this is kind of where we're going to be heading, where down the road, I give you something weird and ugly, and you have to factor it out, and the goal is to get a parenthesis times a parenthesis. All right, so just real quick video. In a nutshell, what are we trying to do? We're trying to find out what is the opposite of distributing, multiplying into the parentheses. And that answer is factoring. The main purpose of factoring is just undoing distributing. Down the road, we're going to have stuff that you look at and you're just like, there's nothing in common. I can't take anything out. And so we need to have strategies for how to factor or how to pull stuff out of that. So hope you enjoyed that video. If you have any questions, let me know. Give this channel a subscribe and a like, and we'll see you soon.